So we left off on secret word on 146 and kind of do a little bit of review on that real quick. Um, so basically what this is, again, when we're dealing with strings, we just can't use the double equal sign because the double equal sign has a lot more, um, it has more than just, you know, primitive values are just numerics. That's all they are. When we use a string, we're actually dealing with a class. With a class have methods. They have all of these other different parameters that are inside there. And one of the things they have is this thing called hash code. And the hash code, and I think we'll actually see some hash code in another chapter. But the hash code, every object has its own social security number. And that social security number is called the hash code. So if we tried to take two different objects and to compare them with a double equal sign, they will never equal because of the different parameters and especially that hash code that's going on behind the scenes. So what we need to utilize is the built-in methods that are built into the string. And one of those is the dot equals. So we could just say dot equals right here. I could say, so in this case here, they want us to type in this word Prospero. And so when I run this, I can click on the run button. And when it runs, it says, as for the secret word. So if I type all caps, Prospero, and I hit OK, it says, congratulations, you know the secret word. But if I run this again, and this time I'm going to type it all lowercase, I type Prospero. When I hit the enter key, it says, sorry, that's not the word. Because again, when we deal with Java and most programs, there's a big difference between a lowercase a and an uppercase a. But what we can utilize, and again, if I'm using, so here I've got string input. So I've created a string object that's called input. I create my scanner keyboard, I ask the user for the secret word. I go ahead and put that next line into the input. And then since the input is a string object, if I type a period behind it, it's going to bring up a list of all the methods and other parameters that we can utilize within the string class. And if I type EQ, it brings up the equals. But you'll notice what's in the book is this thing called equals ignore case. So if I use that, if I utilize the ignores case, it says I'm only going to look at the letters, and I'm going to basically what that method's going to do behind the scenes is it's going to take whatever you typed in and convert it to an uppercase, and then compare it to what's inside these parentheses. So now when I run it, and I type lowercase Prospero, and I hit the enter key, it says, congratulations, you know the secret word. Even though I typed it lowercase, this equals ignores case will basically make sure that they match no matter what. I could even do this. I could run it and I could do Prospero. Notice I've got mixed case in there. When I hit the enter key, it says, congratulations, you know the secret word. So it doesn't matter if it's uppercase or lowercase. This equals ignore case will do just that. Okay. So that's kind of the last thing we left on the other night. So we're going to continue on page 147. And it talks about more about variable declaration and scope. It says the scope of the variable is limited to the block in which it is declared. So this thing is called variable scope. So let's take a look at that program. Variable scope.java. So let's take a look at it. It looks like we're using a J option pane. So here I have my static void main. So I got string first name, and first name equals J option pane. Show your first name. So we type it in. It puts in the first name. And again, first name is going to be a string, and so is last name, and so So basically we're asking the user for the first name and the last name. And then we say J option pane, show message dialog, hello. And we concatenate first name, concatenate a space, and then concatenate last name. And again, we always use a system.exit 0 because we want to make sure that we kill that J option pane because we don't know if just the end of the program will it kill the J option pane because it could still keep running. So it says, so let's take a look at the book. So it says, although the common practice to declare all the variables locals variable at the beginning of the method, it is possible to declare them at later points. Sometimes programmers declare a certain variable near the part of the program where they're used in order to make their purpose more evident. Now, let me say this. I kind of disagree with that because in my years of programming, when I go to look for a variable, I always look at the beginning of the method to see where those are actually declared. If I have to do a search and destroy mission to find a variable that's been declared, that really doesn't make it maintainable because that method could be super, super huge. And if I'm declaring a variable here and here and here and here, that makes it really hard to find those variables. But if they're all declared up front, so if I basically did this, now all the variables are declared up here, and now it's easy to find those variables and what we're going to basically do with them. So if I need to make any kind of a change or whatever the case may be, maybe I need to find out, is first name a string? Is it a char array? Is it, what is it? Well, since I declare everything up front, it makes it easier. So I kind of disagree with that. There are some cases where you may need to declare it right before you use it. One of those is basically when we get into looping, I think is what we're going to cover next week is looping. Am I correct there? Yes. And we'll kind of see some situations where we'll declare a variable right there in the loop when we utilize it. So that's kind of what they're trying to show there is yeah, you can declare that variable wherever you need it. But again, I like to declare all my variables at the beginning of the method so that way if I ever need to maintain it, I know where all the methods are declared. I can find out what they are, that type of thing, the data type, and everything like that. Okay. Now, this next one is kind of wild. It's called the conditional operator. And this is basically just like an if-else statement. Now, let's take a look at it. So, how it works is we ask a Boolean expression. We ask if something is true or false. We put in a question mark, then we put in value 1, value 2. So here's what it says. So here's what here's what it looks like. Y equals x less than 0, question mark 10, 20. What that says is if y, if x is less than 0, we're going to put 10 into y. If that statement is false, then we're going to put 20 into y. So this statement right here is identical to this if-else statement. Now here's my question. Which one's easier to read and understand? Well, obviously the if-else is. And again, for maintainability's sake, I would probably always stick with the if-else. Because even though this takes this if-else statement and puts it on one line, it really, a lot of folks are not familiar with this. And so the conditional operator, and they'll have to kind of look it up and figure out just what in the heck's going on. But if you just use a simple if-else, that's kind of the, everybody knows what an if-else statement is doing. Yeah. Exactly. Because notice it says y equals, and then here's the condition, and here's basically the, if it's true, do this, if it's false, do this. And then it puts it into the y. So see, the y says y equals this conditional statement. Now, when you use the conditional operator like that, you have to have an else statement. You can't just do an if. So, because something has to be put into y, whether the statement is true or false. Like I said, it's pretty slick. I'll see it every once in a while, and I'll have to kind of go, oh, what in the heck's that doing? Oh yeah, that's that goopy thing. So. Exactly. Yeah, because we're saying y is equal to this conditional statement. And it all depends on whether this guy right here is true or false, or what gets assigned. Yeah, because you right down here, you're used to seeing y equals 10 or y equals 20. But no, this says y equals this statement, depending on what that's true or not, it's going to get either a 10 or a 20. Okay. So up to this point, we've dealt with if-else statements. We've dealt with if-else-if statements. Now we've got this thing called the switch statement. And it says the switch statement lets the value of a variable or expression determine where the program will branch to. Basically, it's basically just like an if-else statement, but it's a lot different, I should say. So this is what a switch statement looks like in flow charting. So we come down here and it just says month. If it's a 1, we're going to display January. If it's a 2, we're going to display February. If it's a 3, we're going to display March. Else, we're going to display invalid month. So, what does a switch statement looks like? Well, here's the layout of how it works. We say switch, and inside the parentheses we put in our expression. Okay? And then we have a case statement. The case, and then we state some value. So basically it says if we have this expression, if it's this value, we're going to do this. Now the one thing we want to pay close attention to is this break statement. Break statement is very, very, very important, and I'll show you why here in just a few minutes. So I have my case. Here's my expression, my test expression, and then here's my value, and my value, and then I have a default. And the default basically says this: if it's not that, not that, not that, then it's got to be that, or it defaults to that. So let's see what it looks like. So this is what it looks like taking that flow chart statement. So we got switch month. Notice this is like an if statement. We have a open brace and a closing brace. It says case 1. So if it is a 1. Now, if I'm looking at this, I'm expecting month to be a primitive value, most likely an integer. So month has to be an integer. So I say case 1. So if it happens to be 1, it's going to just do a sysout print ln January. If it's a 2, it's going to print February. If it's a 3, it's going to print March. If it's not 1, 2, or 3, it's going to print error invalid month. Now, the break statement. The break statement says this: if this statement is true, it's going to print January, and then break says get completely out of this switch case statement. If we did not have this break, it's going to continue on. And it will basically do the next one, and the next test the next one, the next one, and then it will do the default. And we don't want that to happen. So, very important to have the break statement. The break statement says, hey, if this is true, let's get out of this switch statement. Now, doing the switch statement would be identical to doing if month equals 1, print January. I think on the next page, yeah. Else if month equals 2, print February, so on and so forth. Else at the very end, invalid month. So let's take a look at the switch demo Java. And here we have INT number. We got our scanner keyboard. We're going to ask the user to enter 1, 2, or 3. And then we go ahead and grab the keyboard, next int, and we throw that into number. And then I say switch number. If it's a 1, so case 1, we're going to display you entered 1. Break. 2, you entered a 2. Case 3, you entered a 3. If we type something other than 1, 2, or 3, it's going to print that's not 1, 2, or 3. And I put some comments in here, and this is identical to this if statement. So that switch case and this if statement are identical. So let's try it. So we run it, and it says enter 1, 2, or 3. I enter a 2, and it says you entered a 2. I run it again. I type in a 4. Hit the enter key. It says that's not 1, 2, or 3. Again, I can run it again and type in a 1 and a 3, and basically it's going to work just fine. So any questions on the switch case? Okay, so now what happens if we didn't have any break statements? So let's open up the nobreaks.java. Nobreaks.java. So here we have that same situation. You entered a 1, you entered a 2, 3, so on and so forth. So let's go ahead and run this. And let's go ahead and type in a 1. I hit 1, and look what happens. You entered a 1, you entered a 2, you entered a 3. That's not a 1, 2, or 3. So it just keeps going. So let's run it again, and this time type in a 3 and watch what happens. It says you entered 3, and that's not a 1, 2, or 3. So basically here's what happens. So when I typed in a 3, it says case 1. That's not true. So it goes to case 2. That's not true. Case 3, oh, that's true. It executes that, and then it basically executes everything else after that. It just keeps on going. So once it executes one of these statements inside of the case, it will execute the next, the next, the next, and the next, and so on and so forth until it basically gets out of the switch case statement. So that's why breaks are needed. The breaks basically say, hey, once that's true, let's get completely out. We're not going to do anything else inside this switch case statement. We're done with it. Okay, yeah. So the next thing we have is this thing called petfood.java. So let's open up that guy. And so here's my public static void main. I've got string input. I've got char food grade. I've got scanner keyboard, and I've got sysout. Our pet food is available in 3 grades, A, B, and C. Which do you want pricing for? I say keyboard, next line. And then what I do is I'm going to grab just the first character of whatever I entered. I'm expecting A, B, or C, but if somebody happens to type something more than that, all I'm grabbing is the very first character. So I'm going to take the input, which is a string, and then I say input.char at. And this says grab the character at position 0. Remember, in Java, everything starts with 0. So in this case, it's going to grab the very first character. So now that I'm using a char now, because food grade is a char. So I come in here and I say switch food grade. And I say case single pick A single pick. Now, I think I've talked about this before. For chars, we can only use single picks. We can't use double picks. We can only use single picks. So now look what we're doing. I've got case single pick A single pick, or lowercase a, or case uppercase A. So this is kind of like an or statement. If it's case lowercase a, or if it's case uppercase A, it's going to print 30 cents per pound, and then it's going to break and get completely out. If I typed in a lowercase b or an uppercase b, it's going to basically say 20 cents per pound, and then breaks, get completely out. Lowercase c, uppercase C, 15 cents per pound. Breaks, get completely out. If I typed anything but A, B, or C, it's going to basically print invalid choice and then basically get out. Now you'll notice I don't have a break statement on the default. It's not needed because that's the very last statement in the break or the switch case, but it's probably good practice to always put one in. Okay, so let's run this. And if I type in a lowercase b and hit the enter key, it says 20 cents per pound. I run it again, and this time I type in an uppercase B, I get the same exact thing. So with a switch case statement, we don't use an or. The or, we just basically put two case statements side by side, and that is an or statement. That's basically saying if food grade is a lowercase a or it's an uppercase A, it's going to print 30 cents per pound. Any questions on that? Because you did not put in an A, B, or C, you put in something else. Did you type a space before it? You might have try it again. So run it and just type in a B right there, and it should say 20 cents per pound. Did it work? Okay. Let's open up seasons. So this one's a little different. This time we're using string data. So I've got string input. I got my scanner keyboard. I'm asking the user for enter the name of a season, and I use the next line to put it into input. Now I'm just going to take input, and case spring, it's going to print La Primavera, and then it breaks. Case summer, it's going to print El Verano. Case autumn or case fall, because some people call it autumn, some people call it fall, it's going to then print in Spanish El Ontano. And if it's case winter, El Inverno. I'm sure I'm butchering this. I don't speak Spanish. And then if it typed anything else but that, it's going to print, please enter one of the following words. Notice the new line character, spring, summer, autumn, fall, or winter. Now notice, it's expecting everything to be written in all lowercase. If we wanted to really do this, there is a way for us to convert it from uppercase. We can convert it to all lowercase, we convert it to all uppercase. So let's run it. And if I type in fall and hit the enter key, it says El Ontano. And if I run it again, and this time I type in autumn, whoop, I misspelled it. Oh, A-U-T, okay. I thought it's got an N on the end. That's what screwed me up. So AUTUMN, hit the enter key, and then there's also El Otano. So switch case is, again, if you're going to have a lot of, so if you're ever going to use an if else if, you should probably consider using a switch case. The ORs are going to be a lot easier to use. You don't have to use the double ampersand or the double pipe symbol. You just have two case statements, and that's just like an OR. Yeah. If it is, we're talking milliseconds, so it really doesn't matter. As far as the compiler's pretty much going to compile them the same. So the machine language is pretty much going to be the same exact thing, whether it's an if else if or whether it's a switch case. Um, I think the switch case is going to be, I mean, we're talking milliseconds. Um, and here's what I was told. Electricity travels 89,000 something feet per second. And they said if you took a if you took a pepper shaker and put some pepper out on a piece of paper, and that little tiny speck of pepper is how fast the electricity moves in 1 second or 1 millisecond. So 89,000 feet per second, and that's how far it moves in 1 millisecond. So, yeah, so it really, again, it probably, it won't matter. That's a good question, though. That's a good question, though. Um, let's see if we can. Okay, this last section of the chapter is all about the printf method. It allows us to format the output in a variety of different ways, meaning that we can, for one, we can round to decimal places, we can use 1,000 separator, we can set the width, all kinds of different things. So, so for example, they said in the book, if you have a double variable called number, and you do 10 divided by 6, and you print that number, it's going to print 1.666666667. And so what we can utilize is this thing called the system.out.printf. So we've seen print, we've seen printl, and now we're going to talk about the printf statement. And so what we do is we have our string that we want to print, and then we put in our argument list. And those are basically variables that go into the format string. So in the simplest form, we can just do system.out.printf, I love Java programming /n. Now, with the printf is just like the print. There is no line, new line statement at the end where it automatically goes down to the bottom. So, so we have to put in the /n. Okay, just be aware of that. So here's the basic of how we utilize it. We use what's called the format specifier. Okay, in this format specifier, we're going to really specify whether it's a floating decimal point, a integer, which is a D, or an S, which is a string. So the first example we use is just a floating decimal point. So I've got double sales 12345.67. Now here's how it works. We got our sales are %F for the day. Now the percent says this is where that variable is going to be placed. The F says this is the data type I'm expecting. I'm expecting a floating decimal point. So that is the string that's going to print. This is the argument. So sales will be placed wherever there's a % sign. The very first % sign that occurs in that statement, and sales is going to go into it. So what's going to happen is our sales are %F for the day. It will print our sales are 12345.670000. Now, the default for the floating decimal point is 6 decimal places. That's the default. So if we don't specify anything as far as decimal points, we'll see what we can do here in a second, is if we don't specify that, it will automatically default to 6 decimal places. Okay? So again, I just explained that. It says that the sales go into whatever the very first percent sign that basically occurs in that statement. Now, what if I did temp 7.72.5 and temp 283.7? Well, notice I now have 2%F statements, and I've got 2 arguments at the end, temp 1 and temp 2. Temp 1 will automatically go into the first percent sign. F, again, it's expecting a floating decimal point, and temp 2 will automatically go into the first percent F, or the following percent F, I should say. And so again, what it will print is 72.5, and again, 6 decimal places, and 83.7 and 6 decimal places. Again, that's kind of what's going on. So temp 1 goes into the first, temp 2 goes into the second. Again, I can do I can do as many as I need to do. In this particular case, I've got %F, 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 /n. Notice that all these statements do have a /n in it, so that automatically drops down to a new line automatically. And again, I got value 1, value 2, value 3. Value 1 is going to go into the first one, value 2 will go into the second one, and value 3 will go into the third one automatically. Now, the next one is the D, which stands for decimal integer. I always thought that was kind of strange that they chose decimal integer, but basically it's a whole number. So I've got int hours equals 40, and I said I worked %D hours this week. Now notice I've got hours, comma, hours at the end. So that is expecting, so hours will be placed here, and again, it's expecting a decimal integer to go into there. And it will then display, I worked 40 hours this week. I can have int dogs equals 2, int cats equals 4, and we have %D dogs and %D cats, and again, dogs is going to go into the first %D, and cats will go into the second %D, and it will print we have 2 dogs and 4 cats. So now, let's get a little more precise. So here's what we can do. We have what is called a flag, a width, a dot precision, conversion. So percent is all, so that basically is the format specifier begin. That says this is where we're going to place the parameter, whatever follows that % sign. The flag after that are optional flags that we can basically utilize in different ways. We'll see how we can use those in a second. Width, after any flags, you can basically specify the minimum width for a value. Now what that means is, how many characters is it going to display? 6 characters, 7 characters, 8 characters, so on and so on. The dot precision says, how many decimal places do you want to round this to? And again, this only basically is valid for floating decimal points. And then the conversion is basically the F or the D, and again, we'll see in a few minutes here, an S for strings. So let's take a look at precision, the dot precision. So here I've got double temp 78.42819. Down here I say the temperature is %.2F. What that says is round to 2 decimal points. And F says I'm expecting a floating decimal point. So the temp will automatically put into there, and when it prints, it will print 78.43 degrees. Notice that there's a 8 after the 2. That forces that 2 to round up to a 3. So it will basically display 78.43 degrees. So let's take a look at this. I've got the same exact value. It's got 1, 2, 3, 4, 5 decimal places and all 3 numbers. The first one I've got %.1F, %.2F, %.3F, and then a new line character. So value 1 is going to go into the first %, 2 is going to go into the second %, value 3 goes into the third %, and then look what it did. It basically rounded that to 1 decimal point, rounded to 2 decimal places, and rounded to 3 decimal places. Okay, so the precision, we can round to a specific decimal place. I could actually say 0.0, and that will round to a whole number and basically have no decimal place. So the next one is the minimum width field. Now this is the minimum width. And let me explain that, what I mean here in a second. So it says the number is %20f. So 20 says this is going to take up 20 characters. If it doesn't, numerics will automatically be aligned to the right, and it will basically space fill in the front. So if we look right here, we've got a whole bunch of spaces in front of this numeric value, because this guy from here to here is going to take up 20 characters. And notice that it had 4 decimal places, and it added 2 more because we didn't specify the decimal places, so it defaults to 6. So there's 5, 6, and then 6 more. So there's 12 characters, so there's basically 8 spaces in front of this number. That's what they're specifying down here. The number, okay, now look at this one. I say the number is %1f. Now this is the minimum width. It says it's going to take up at least 1 character. If I have more characters than that, then it will default to whatever the number of characters are. So it will basically, in this particular case, since I didn't specify a precision, it will basically put 6 decimal places, and look at that. It displays the entire number. So that number is the minimum width. If the number of characters exceeds that, it will go ahead and display that, how many numbers there are. We can do the same thing with the decimal integer. So I got int number 200. The number is %6d. There's 3 spaces in front of that 200 right there. It will basically do that. So now let's kind of, if we combine them, we can actually do that as well. So here I've got double number, and basically it's got 4 decimal places. I said I want it to take up 12. I want the minimum width to be 12, and I'm going to round to 2 decimal places. So now I've got 5, 6, 7, 8, and since I said 12, there are 4 spaces in front of this. So again, that's the minimum width. So let's go ahead and take a look at columns. And we'll expand that, and let's open up columns. So we take a look at this. I've got 6 variables. They're all doubles, and look at it. I've got varying different decimal places and numbers in front of, to the left of the decimal place, so on and so forth. It looks like they're all 3 decimal places. But if we look down here, I'm doing a printf. I'm saying I want the minimum width to be 8, and I want all of the decimal places to be 2. Now here's what's nice about this. Since it automatically aligns right, watch what happens when we run this. It basically aligned all the numbers to the right and space filled in the front, because every single one of these, there's 1, 2, 3, 4, 5, 6, 7, 8. So there's 8 characters in each one of these. What's nice about this, since we rounded to 2 decimal places and we basically had a minimum width field, it basically aligned everything to the right and lined all the decimal places. So it's kind of a nice way to align all your decimal places by using a minimum width field. Now here's another problem with this though, is let's say I'm going to add a couple numbers in front of this number. Again, that's a minimum width. Watch what happens when it runs now. That guy got shifted over. So if you're wanting to align your decimal places using a minimum width field and decimal places, you got to make sure you put the minimum width for the largest number that could possibly go in there. So, okay. So basically, yeah, so there's that. So now we've got a new one, and it's called, another flag is called the comma separator. And so when we have 1,000 separators, we just saw in this one right here, I have Look at that. That's a million. So there should be 2 commas in there. So guess what printf will do for us? Printf will automatically put in a comma in a 1,000 separator spot. So in this case here, I've got 1, 2, 3, 4, 5, 6, 7.89, and I got percent comma f. Notice I didn't specify a decimal place. So guess what's going to happen? It's going to basically make it sure it's 6. So when this guy runs, it's going to be 1,234,567.89 and then 4 zeros. But look at, we could do this. I could have done the same exact thing, and this time I've got the sales for the month are comma 0.2 F. And that's going to basically do 28,756.89. So let's apply this to the currency format program. So let's open up the currency format. And there I've got double monthly pay is 5000.0, and the annual pay is a monthly pay times 12. And it says your annual pay is $. Now, $sign has nothing to do with the printf. It's just going to print the $. And there's my percent, comma 0.2 F/N. And annual pay is going to go into wherever that percent sign is. So when I run it, it comes out your annual pay is 60,000.00. Now look at this. I've got 1, 2, 3, 4, 5, 6, 7.8901. I say percent, comma 15. So 15 is now the minimum width. And 0.2, we're going to round to 2 decimal places. And again, we're expecting a floating point number. And when it runs, it's going to, now there's going to be a bunch of spaces in front here because this is going to take up 15 characters no matter what. Yeah, the following displays the int at a minimum width field of 6 characters. So there's 3. So we saw that one. And we'll display space, 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 200. If I got int number to 20,000, and I do a comma 10, that's going to take up 10 characters, and it's going to put the comma in the 1,000 separator. Now, another flag we can utilize is what's called the padding. Instead of spaces, I can pad it with zeros. I don't know how I can't think of an example where we'd ever want to use that, but that's possible. So I could do percent 08.1, and that says I'm going to pad with zeros. It's going to be a minimum of 8 characters wide, and we're going to round to 1 decimal place. So when this prints 123.4, it's going to be 000,123.4, and that's 1, 2, 3, 4, 5, 6. Counting the decimal point is 7, 8. So let's take a look at leading zeros.java. And so here I've got 1.234, 12.345, 123.456, and here I'm saying I want leading zeros, minimum of 9 characters, and I'm going to change that to a 2, and round to 2 decimal places. So now, so we're going to put number 1 there, number 2 there, and number 3 there. And now when it runs, notice we got the new line character in each one. And now when it runs, all leading zeros, instead of spaces, it's going to have zeros. And again, everything aligns to the right. So we can lead with zeros. We can have leading zeros in the front, padding, or we can have spaces. We can also left justify numbers, and the way we do that is we put a minus sign in front, and that will basically left align everything. So let's take a look at left justified. So here I've got 1, 2, 3, 1, 2, so a whole bunch of different varying numbers, and these are all integers. And here I've got printf -8, so that says left justify a minimum of 8. Width, character width, and again, B says I'm looking for a decimal integer, and then looks like we're going to have 2 numbers in there, and same thing, percent -8D, And then notice this num1 is going to go in this first percent, num2 is going to go in the second one. And same thing for the 3 and 4, num5 and 6. And again, when we run it, all the numbers are now left justified, and the spaces over here. So there's 1, 2, 3, and there's 5 spaces. And then 1, 2, and I'll watch. There's 1, 2, 3, 4, 5, 6, 7, 8. 8 characters. If I hit the right arrow one more time, it automatically goes down to the next line. There's 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. Come down. There's 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. So there's 8 characters, and since we got the minus sign, they're left aligned. Now, we've talked about floating decimal points, we've talked about decimal integers, now we talk about strings. How can we utilize the printf for strings? Well, here I've got string name Ringo, and I've got system.out.printf. Your name is %s this time. And then /n, again, we want to automatically go to a new line after this. So the name is going to go into the first %s, and it's going to display your name as Ringo. So here we've got George, Franklin, J, Ozzy, Carmine, D. So again, minimum width of 10, an S. Okay, so name 1 is going to go in the first one, name 2. Each one's going to be 10 characters wide, and again, right aligned automatically. So if we take a look, if we run so if we look at this one, it's going to run like this. It's going to pad all the spaces in the front, have George, spacing, Franklin. Again, everything's right aligned. We can use the minus sign to left align, so we run the same exact program again, except this time we're going to have it left aligned. Now we've got George, and then the padding of spaces is on the right. Okay. Now let's mix it all together. We can do this. We can say int hours equals 40, double pay equals hours times 25, and string name J. So now here I've got name, %s, hours, %d, pay, $, %, comma, 0.2f, so it's going to have a 1,000 separator, and then 0.2 decimal places, /n. So name is automatically going to always go into the first %. Hours will always go into the second %, and pay will go into the third %. And when it runs, it's going to say name J, comma, hours, colon, 40, comma, pay, colon, $, 1,000 with the 1,000 separator. So we can mix and match. We don't have to just stick with floating decimal points or decimal integers. We can mix strings in there as well. Okay. Now, this last section is going to talk about the decimal format class. So we've seen the string class, and we've seen all the different methods that come with the string. This is the decimal format class. And what I'll just to do is to formalize how we want it to display on the screen as well. So the printf does it, but the decimal format will do it as well. So the printf was just going to print in the console. What if I want to use something like a J option pane? Well, I can't use a printf and a J option pane, so I have to basically, I would need the decimal format class to format numbers like I would with the printf. And so here's how it works. First of all, we have to import the decimal format class. It doesn't automatically come in like a string. And here's how it works. So we basically say decimal format. I'm going to create a formatter object, which is a decimal format object. Now again, remember, on the left-hand side, that declares the object. The object's sitting there with an empty shell. There's no guts inside of it. On the right-hand side, that's where we put the guts and all the methods and everything that comes with the decimal format gets put inside. And that's called instantiation. I can see that with the new, that instantiates as a new object. And we have some parameters in here, #0.00. Okay, we'll talk about these in detail in just a second here. So we got the formatter variable references a decimal format object. So formatter is the object, and the decimal format object has this pound sign 0.00. Now let's just take a look at format 1 to kind of get a feel for how this works. So let's take a look at this. I've got 0.1 and a whole bunch of 6s and 7s, and that number, and that number, and that number. Okay. Down here, I declare my decimal formatter. Now this name right here, this can be anything you want. I could name this George if I wanted. But again, we always want to make sure our variable or object names have good explainable names to them. So instantiated as a new decimal format, and I've got pound sign 0.00. Down here, I do a J option pane, show message dialog, formatter.formats. Now look, since this is a decimal format object, if I type a period behind it, look at all the different methods that come with the decimal format class. Okay, we're going to just be utilizing the decimal format, or the format method. We're going to put the number 1 in there. Now here's how it works. It says, if there is no, I'm going to call this 10 cents and cents. If there's no cents, it's going to put a 0. This 0 here says if there's no tens, it's going to put a 0. This says if there's no dollars, no single dollars, it will always use a 0. The pound sign, though, says if there's no number that goes there, don't put anything. The 0 says if there's nothing to print, put a 0. The pound sign says if there's nothing to print, print nothing. That's what that means. So if we look up here at this guy up here, it's got 0.111167. Since there's a 0 there, watch what happens. So let's run this. And I've got 0.17, so it rounds to 2 decimal places. 1.67, 2 decimal places. 16.67, 166.67, and then the program stops. Now watch what happens when I put a pound sign here. Remember what the pound sign says. If there's nothing there, 0 means nothing. If there's nothing there, don't print it. So watch what happens when we run it again, and look what pops up for this first one. It just prints 0.17. So the pound sign is really powerful. The 0 says if nothing to print, print a 0. And again, nothing is also 0. Okay, so now this time let's run it with format 2, and this time notice that our decimal format has 00.00. Now let's watch what happens there. We'll see that on number 2. That's really going to make a difference. So we run it. 00.17, 01.67. And then 16.67, and then 166.67. So as you can see, that 0 says if there's nothing in that $10 mark, put a 0. Okay, let's take a look at decimal form or format 3. So now look at this. So now I've got 123.859. And basically we can see a whole bunch of different numbers here. This time I've got pound sign, comma, pound sign, 0.00. Now we know what's going to happen if the 0 says, if nothing to print, including a 0, leave a 0. Pound sign said there's nothing to print, including a 0, print nothing. But now we've got a comma in there, and a comma says if there's a 1,000 separator, print a comma. So let's see what that does. So the first one is just 123.86. Here's our 1,000 separator. There's our 1,000 separator. There's still our 1,000 separator. Look, now we're in the millions, and there's 2 commas there. So it automatically puts it for the, any time there's 3 digits, we'll put a comma. Okay, let's take a look at format 4. So this one, it also works for percents. So in this case, I've got 0.12 and 0.05. And here I've got $0. What that will do is that will convert it to a percent automatically. And if there is, basically what they're saying is there has to be at least one digit displayed. If there's nothing, it will print a 0. The second digit is optional. Okay? So if we run this, watch what happens. It automatically converts the 0.2 to 12%, and it prints the 0.05 to 5%. Now, if I put a 0 here instead of the pound sign, watch what happens to the 5%. Puts 0.05%. That probably is not a good idea for percents. It's probably best with the pound sign. Okay, so that's it for chapter 3. If you have any questions, again, make sure you contact me. I'd be happy to answer any questions you have. We'll see you next time.